Assalamu alaikum. This is MATLAB Lecture number 8. In this video, we will solve the exercises. Exercise number 1, it says that solve the following differential equation with the initial condition dy over dt plus 4y of t equal e to the power minus t. We have initial condition y of 0 equal to 1. Now, as you see, CLC clear, close all. Here we have system, the function is y, function of t. So we have to remove the x, write function y of t. Now we have to write the ODE. The ODE equal to first derivative of y plus 4y of t, plus 4 times y equal e exponential of minus t. Now we want to write the initial condition y of 0 equal to 1. We can write condition equal y of 0 double equal to 1. So now the ordinary differential equation with condition defined. Next, we have to say that we want to solve the ODE, SOL equal D, solve the ODE with condition, and then we want to plot as example the solution. Keep this as say that comment, because maybe I need it later. So plot SOL dot x, no need because we have just one value, not structure. Save the file, run. We have a problem in line number 6, sorry. Here, yes, it is something multiply 4 multiplied by y. Run the program again, y capital. Where is y capital? Here, it's by mistake. It's in line number 6 also. Oh, sorry, it's y small. Run the program, okay. This is the solution. Done. Next exercise, number 1, part B. Solve the following differential equation with initial condition. Same thing, we have initial conditions. Okay, the equation is 2x to the power 2. Okay, same thing. Here we have function y and x of, it is y function of x here. So y function of x. Write the ODE. The ODE, it is equal to 2 times, as you see here, 2 times x to the power 2, 2 times x to the power 2. Let me write them like this better. Okay, in brackets, times second derivative of y. It is diff of y versus x, second order, but because we define it here as y of x, I think better to remove it. Okay, so diff of y to 2. Next, plus 3x plus 3 times x times dy over dx times dy, which is diff of y. Okay, diff of y, then minus y. Double equal, as you see the value here, it is 0, equal to 0. This is the definition of the ODE. And we need the conditions. We have two conditions, y of 1 and y prime of 1. So to do that, we can say that dy as example equal diff of y, just to write the condition. So we can write condition number 1, y of 1 equal to 1, and same thing we can write condition number 2. Condition number 2, it is y of 1, y prime, so it is dy of 1 equal to 0, and then we can write cond, it's just a variable name, equal condition number 1 semicolon condition number 2, and we want to make the solution solve ODE with condition. After solving, we got two values, the value of y and the value of sorry, we get one value, y value. We want to plot the y value, plot the solution. Save the program, run, and check. Better to keep semicolon here, but this is the solution. This is the solution for the y. Okay, and this is as you see the solution here, we have one by one symbolic function, symbolic value. Okay, part number C. Part number C, solve the following differential equation with initial conditions. This is second order differential equation, same story. We have here y function of x, so keep it same as y of x, dy, because we have y prime here, I will keep it also, dy equal dif of y. The ODE equal to the second derivative of y, so we will keep, say that diff of y to x, but second order, like this, equal to the right side view, the right side, the right side one, it is xy of x. It's xy of x, so it is equal to x times y. The condition number 1, y of 0 equal to 1, keep it same, but y of 0, not y of 1. And condition number 2, y prime, dy of 1 equal to 0. So dy of 0 equal to 0, dy of 0 equal to 0 as written here. So we have the cons, same thing, solution. Now here the solution, it will be for y, run the program, we got the solution. See, this is the y, and here are the variables. Next exercise, exercise number 2. Next exercise, in exercise number 2, solve the following system of several ordinary differential equations. Now here, as you see, we have v and z. V function of time and z function of time. So we need v, same of v function of time, and we have z of time. We have to write the differential equations. We can say that, we can say, no need for this one, we can say that ODE1 equal dv over dt, differentiate of v with t, it's first order, and it's equal to -4, it's equal to minus 4 times v plus 3 times z. The second ODE, let me copy the first one. The second ODE equal, as you see, dz over dt, which is different dif of z, and it's equal to 4v minus 3z. 4v minus 3z. Regarding the initial conditions, condition number 1, it is v of 0 equals 0. It is v of 0 equal to 0. And the second, it is z of 0 equal to 1. The second condition, it is z of 0 equal to 1. Same thing, cond equal condition number 1 and number 2. Solution, solve the ODE. So we have to form the ODE. ODE equal to a vector. In the first row, we have ODE1. In the second, it is ODE2. Semicolon, I don't want to see them in the command window. Now we have solution. So remember that sol, it will be a structure, have two values inside it. The one, it is the z, the one, it is the v. So we can't write f plot sol. We want to plot sol dot, the first one, it is v, and the second one, f plot sol dot z, and you can change the legend from x to v and z, the second one, like this. Save, run the program. I will show you the figures. So as you see, you have two values. The first one, the red one, it is the z, the blue one, it is the v. And as you see here, the solution is structure. Inside the structure, we have z and we have v. This is why we wrote here sol.v, sol.z. Now, question number 3, exercise number 3, solve the following system of several ordinary differential equations. As you see, dv over dt, dz over dt, du. We have three equations here. So the variables they are, or functions, we have v, z, u. So we have to add u of t, all of them function of time. Okay. The first ODE, it is dv over dt, so diff of v equal to minus 4v plus 3z. It's okay. The second one, it is diff of z equal to 4v minus 3z, exactly same. And we have to write the third one, Control C, Control V. The ODE3, the third differential equation is, it is diff of u, first order derivative of u, and equal to 4u minus 3z, 4u minus 3z. Our initial conditions, and before that, the ODE equal ODE1, semicolon ODE2, semicolon ODE3. Okay, now what about conditions? Condition number 1, v of 0 equal to, v of 0 equal to 2. And the second condition, z of 0 equal to 1, it is same. And the third condition, Control C, Control V, the third condition, it is condition number 3, equal u of 0, u of 0 equal to 0, as written in the question. And this is the conditions. Good. Now regarding solution equal d solve ODE. Just be sure ODE 1, 2, 3. Conditions 1, 2, I forgot. We have cond 3. Okay, so conditions are there, ODEs are there, ODE2 not used. Why? ODE may not be used. No, it's used here. ODE2, ODE2. Why giving me not used? Okay, never mind. Let me save the file and check what will happen. Regarding the plot, we have three values here. We have solution.v and .z, and the other one, Control C, Control V, the solution.u, three solutions. And we have to add more string, extra string, or the third string, it is for u in the legend. Save, run the program, let us see what will happen. ODE, same, undefined function, ODE3, it's in line number 9. In line number 9, it's ODE2. And this is ODE2. Okay, now because here we have ODE2 double time, so ODE 1, 2, 3, now it's okay. Save the program, run. I'm waiting for a solution. We have another problem in line number, what's wrong here? It's in line number, I don't know what's this mistake. Let me again write again the equation. It is dv dt, differentiate dif of v, equal minus 4v plus 3z. The second one, ODE2, equal dif of z, equal 4v minus 3z. The last one, it is dif of u, it's equal to 4.
Check line number 15.
ODE3, it's okay. 4, it's okay. Condition number 1, it is good. Condition number 2, same. Condition number 3, same. Cond equal cond, semicolon, yes, semicolon here. Okay, now save, run the program again, and wait for the result. Yes, we got 3, as you see, three graphs, V, U, Z. And as you see here, the structure, inside the structure SOL, again, SOL, it's not a keyword, it's just a variable name. You can name it any name. As you see, we have structure Z, V, U. This is why we wrote here sol.v, sol.z, sol.u. We use the subplot. Yes, here, I'm sorry, I forgot to use the subplot instead of plot. How we can use the subplot? Regarding subplot, before here, we can write subplot. Say that if we have 3 figures here, we want to order them in, say that line by line. So we have 3 by 1. So 1 column, 3 rows. This is drawing number 1 or plot number 1. F plot solution. No need for the hold in this case. Okay, and no need for the legend in this case. Just write subplot like this, Control C, Control V. Next one, it will be number 2. It is 3 by 1, but this is graph number 2, and here it will be 3 by 1. It is graph number 3. Graph number 3. Now save. Again, I'm sorry, it should be in part number B, question number 2, subplot also. But never mind, this is how we can use the subplot. Just wait for the result and for the plot. See, this is the subplot. We have plot number 1, number 2, number 3. Surely we have to use the title for each one, the color, the grid on, everything. But how we can do that? Subplot 3, 1, 1, drawing number 1, F plot. We can use here hold on, if necessary, hold on. We can use here after the plot grid on, and we can use title, label, axis, whatever. Okay, same thing for the second one. So same thing for the second one, and all of them. Run the program. See, here we have grid on, here we have grid on, but for the second one, not yet. You have to fix it. Okay, this is how we can use the legend. Thank you so much. See you in next video.